Hello, my name is CJ Thomason, and today I will be giving a brief lesson on the autonomic nervous system. The autonomic nervous system is divided into two different systems. Sympathetic, which allows the body to react under high stress. This is commonly referred to as fight or flight. And parasympathetic, which allows the body to do work under normal conditions. This is commonly referred to as rest and digest. The sympathetic pathway is your body's natural response to danger. Let's take a look at an example. Let's get scientific up in here. I want you to picture this scenario. Imagine you're out in the forest going for a hike and suddenly out of nowhere a wild animal hops onto the trail. Now, your brain, being the very smart organ it is, recognizes this animal as a potential threat. So, your brain sends itself into sympathetic pathway mode. What happens during this is your heart begins to pump faster. This allows oxygen to reach your brain, allowing you to process quicker. Your lung bronchus also dilate, allowing you to take in air quicker. Also, your digestion tract is inhibited, allowing more ATP and glucose and energy to be used for other things, like running, or getting away, or even screaming. Isn't that fascinating?
This isn't even a real animal. Oh!
Let's take a look at how this is all possible. Now, I understand this could be a lot of information to take in, so you probably have a few questions for us.
How does my brain tell my effector organs what to do, CJ?
Well, Caleb, that is a good question. And the answer actually lies right here.
These are balloons.
No, Caleb. That is an effector organ. And these are called ganglion. Ganglion are little nerve cells at the end of a preganglionic nerve fiber, which connects to your brain. When your brain feels stressed, it'll send a signal through this fiber to these ganglion. And attached to these ganglion are postganglionic nerve fibers. And attached to those are nicotinic ace chlorine receptors. And you know what those do?
No, but I'm pretty sure you pronounced it wrong.
Those send off a neurotransmitter called acetylcholine, which stimulates your effector organ, allowing it to do work.
Okay, that's silly string, and I'm pretty sure you're using the cheat sheet. Seriously?
Hello!
What? What are you doing in my shower?
Bet I gave you a start there, didn't I?
I have a date in half an hour.
Not with that hair, you don't. Alright, do you know why you jump so much when you're scared? Well, you see, in your adrenal glands, there is this thing called the adrenal medulla. Do you know what that does? When you're frightened, it sets off a stimulant called epinephrine. Do you know what else that is called? Adrenaline. Is this yours?
No.
Anyways, adrenaline affects both the heart and the lungs. In the heart, it causes your heart to speed up, which raises your blood pressure way high. It also dilates the bronchi of the lungs, allowing you to breathe faster. Come on, let me show you something.
I have a date!
Let's take a look at a few organs involved in parasympathetic action. These are your organs. Each of the organs have different receptors on them. Alpha 1, Alpha 2, Beta 1, and Beta 2. Each of your organs have different receptors on them. For example, the heart commonly has mostly Beta 1. The lungs have mostly Beta 2 receptors. And blood vessels have mostly both Alpha 1 and Alpha 2 based on their location in the body. Now, what these receptors do is they trigger multiple neurotransmitters. These neurotransmitters that come from the brain tell which organs to do what. That way, you don't contract your heart when you're trying to calm down. I can see you've dozed off. Your vagus nerve has slowed down your heart and sped up your digestive tract. Your ionotropic and metabotropic receptors are now active, allowing you to be in parasympathetic mode, allowing deep relaxation. Well, kids, that's the lesson for today. I hope you've enjoyed it. Isn't science fun? Now you better wake up or you're going to miss your date.